Welcome to this presentation on CEREC Zirconia Plus. CEREC Zirconia Plus is a CAD/CAM machinable all-ceramic based on zirconium dioxide. It is indicated for fabricating anterior and posterior crowns as well as bridges. CEREC Zirconia Plus has not only succeeded CEREC Zirconia, but also the whole Inchorus family of products and will replace them entirely. Please note that the new CEREC Zirconia Plus will be distributed under new order numbers. For a transitional period, both product generations, CEREC Zirconia and CEREC Zirconia Plus, will be supplied. The product switchover will take place at distributor level. CEREC Zirconia Plus is tied into the full Dentsply Sirona digital workflow. The first step in the procedure is scanning the preparation, for instance with the CEREC Prime Scan. The proven CEREC OmniCam, still among the smallest scanners on the market, is a viable alternative. CEREC Prime Mill is the grinding and milling unit that utilizes state-of-the-art technology and CAM strategies to produce outstanding chairside restorations easier, faster, and more precisely than ever. A modern setup for achieving predictable results. The in-lab CAD/CAM series can also be used. The CEREC SpeedFire furnace fires CEREC Zirconia Plus restorations within minutes to attain their final strength properties. Then the restorations are ready for placing. CEREC Zirconia Plus can be processed with chairside Dentsply Sirona CAD/CAM devices, where CEREC software version 5.1.3 with material pack or higher is installed. The CEREC Prime Scan indicates automatically when a new version of the CEREC software is available. Any patch releases to the existing version are free of charge for users, but major and minor version updates are charged for. However, members of the CEREC Club are supplied with the next version free of charge. For in-lab devices, CAD 20.0.3 Service Pack and in-lab CAM 20.0.1 Material Pack or higher are required. Which burr is best indicated depends on the milling unit in use. Various combinations are indicated for the CEREC Prime Mill, a combination of burr 2.5 ZRO2 CS for the left side of the machine and burr 1.0 CS for the right side of the machine is best indicated for dry, fast, and fine milling. These milling tools are shown on the left and right of the picture. Other combinations are feasible. For the CEREC MCXL Premium Package, CEREC MCXL, CEREC MCX, and CEREC MC, Shaper 25 as well as Finisher 10 are recommended. For the CEREC MCXL, Shaper 25 RZ and Finisher 10 are the right choice if wet milling is preferred. The manufacturer, however, recommends milling dry in order to prevent inadvertent contamination by particles left in the water after milling previous restorations. These particles may impair the shade match of the restoration. For further information, please refer to the instructions of the milling unit in use. With a global market share of 9%, Katana from Kurore is CEREC Zirconia Plus's main competitor. Of all CAD/CAM dental ceramics, dentists use Ivoclar Vivadent IPS Emax CAD the most. The Dentsply Sirona portfolio includes CEREC Tessera for this target group. How has CEREC Zirconia Plus been enhanced compared to its predecessor? Above all, the translucency of Zirconia Plus has been improved by increasing it to 45%, which provides for a better shade match between the restoration and residual tooth structure. However, many properties remain unchanged. The price of CEREC Zirconia Plus remains considerably lower than that of Kurore Katana. A monoblock is 17% and a mediblock 46% cheaper. The shade range still includes 10 Vita colors, A1 to A4, B2, B3, C2, C3, and D4. CEREC Zirconia Plus blocks are still monochromatic. CEREC Zirconia Plus is indicated for fabricating anterior and posterior crowns and bridges. Sintering, polishing, and glazing are also identical to the predecessor. CEREC Zirconia Plus is sintered and polished, whereby glaze firing is optional. The strength of CEREC Zirconia Plus continues to be very high at approximately 1,000 megapascals. This value is determined using the 3-point bending test. For the 3-point bending test, just visualize an elongated ceramic specimen resting on 2 supports. The specimen can only withstand a force exerted on it continually up to a certain point. If excessive force is exerted, the specimen will fracture. Often, small surface irregularities or microcracks lead to the ceramic fracturing. Tensile stresses widen these cracks, thus causing the ceramic to fracture. The tensile stresses occur on the opposing surface to where the force is applied, as shown by the white arrows. In the test shown here, CEREC Zirconia Plus achieved 1,000 megapascal strength. The term translucency describes how clear a material is. The higher its translucency, the better it can be seen through. A clear window pane is approximately 90% translucent. CEREC Zirconia Plus is approximately 45% translucent compared to its predecessor, CEREC Zirconia, with about 41%. As the translucency is higher, the natural shade of the residual tooth structure is able to exert more influence on the shade of the restoration. In other words, CEREC Zirconia Plus restorations blend into the dental arc more aesthetically. The translucencies of CEREC Zirconia molar crowns with different wall thicknesses are shown on the left, compared to the CEREC Zirconia Plus crowns on the right. The restorations were illuminated from beneath. It can be seen clearly that CEREC Zirconia Plus is more translucent. This case demonstrates the clinical aesthetic properties of CEREC Zirconia Plus. Thanks to the increased translucency of CEREC Zirconia Plus, the restoration, in this case a lower molar crown, blends harmoniously with the adjacent dentition. The crown was luted conventionally using water-based cement. Like all other zirconia cements, CEREC Zirconia Plus also has to be sintered. But what actually is sintering? Maybe you need a gentle reminder. Sintering is the process of forming a solid mass of material by temperature difference without melting it. Due to the heat, zirconium oxide diffuses across the grain boundaries, thus fusing them together. Let's take a closer look at this process. Prior to sintering, the zirconium oxide comprises single crystalline grains. The scanning electron microscope image shows clearly that although the grains are compacted relatively densely, they are only bonded together weakly. In this state, the zirconium oxide restoration is often referred to as a green body. During sintering, the zirconium oxide diffuses with the adjacent grains. The single grains are baked together, as can be seen in the lower picture. It is easy to imagine how this phenomenon increases the strength of the zirconium oxide ceramic. As sintering reduces the porosity, it also increases the density of the green body. CEREC Zirconia Plus is a 4th-generation 4Y TZP zirconia ceramic. TZP stands for tetragonal zirconia polycrystal and describes the structure of the zirconia crystals which occur in different types of structure, such as cubic. The picture shows the microstructure of the older CEREC Zirconia on the left and that of the new CEREC Zirconia Plus on the right. The CEREC Zirconia grains are 100% tetragonal, where those of the new CEREC Zirconia Plus are 75% tetragonal and 25% cubic. The smaller tetragonal grains increase the strength, whereas the larger cubic grains enhance the translucency. The cubic grains are embedded in the tetragonal matrix. A further difference to the original 3 mol% CEREC Zirconia oxide is that CEREC Zirconia Plus is a 4 mol% yttrium oxide stabilized zirconia oxide. Sintering is associated with remarkable shrinkage of the green body when exposed to heat. This shrinkage also occurs with the competitor's zirconia oxide ceramics. The CEREC milling software takes the shrinkage into account. The restoration is automatically designed and milled accordingly larger. To ensure an exact fit, it is therefore important to always enter the enlargement factor indicated on the block. Even though there's no fire blazing in the CEREC Speedfire, it does heat CEREC Zirconia Plus to achieve its final hardness. The CEREC Speedfire is ideal for firing glass ceramics such as CEREC to Cera, but also for sintering zirconium oxide ceramics such as CEREC Zirconia Plus. The table shown above indicates the sintering and glaze firing times for CEREC Zirconia Plus. Unlike with its predecessor, CEREC Zirconia, the sintering times no longer depend on the shade in use, but only on the wall thickness of the restoration. Please note that the sintering times are slightly longer and the spray glaze firing times are slightly shorter than for the previous product. Dry milled restoration can be sintered faster than wet milled restorations. CEREC Zirconia Plus can be sintered in a CEREC Speedfire furnace or other conventional sintering furnaces such as the InFire HTC Speed or InLab ProFire. The CEREC Zirconia range also includes a meso block for implant-borne restorations. This type of meso block will also be available for CEREC Zirconia Plus early 2022. The meso block will continue to be commercially available until then. The meso block differs from the classic block in that it includes an additional hole. After milling, the crown is screw-retained in the implant via this hole. A prefabricated connector, a so-called tie base, is placed between the two. CEREC Zirconia Plus meso blocks are only available in the smaller mono versions. The illustration on the right shows the procedure for an implant-borne single crown. CEREC Zirconia meso blocks can be sintered in a CEREC Speedfire or InFire HTC Speed furnace. The last stage of treatment involves luting the restoration. The term luting describes the permanent attachment of the restoration to the tooth or cavity surfaces, respectively, using a dental cement. Luting is an important part in the workflow, including for prevention of microbial ingress at the tooth structure or restoration interface. Aesthetic considerations also play a role. You will also be informed about indications and required wall thicknesses of various restoration types in this section. The high strength of CEREC Zirconia Plus allows for thinner walls, permitting less invasive restorations. CEREC Zirconia Plus requires 0.7 mm thick walls for anterior and posterior crowns. For anterior bridges, the required cross-connector area is 9 mm square. For posterior bridges, 12 mm square are required. In comparison, Kura-Ray Katana requires much thicker walls of 0.8 to 1.0 mm and for bridgework connector areas of 12 and 16 mm. Please note that CEREC Zirconia Plus is not indicated for fabrication of inlays or onlays. Hydrofluoric acid is generally not effective in creating surface roughness on zirconium oxide intaglio restoration surfaces. To achieve surface roughness and hence increase bond strength, sandblasting with 50 micron alumina particles is recommended. The procedure is typically carried out by a dental technician using a sandblasting chamber, like the one shown in this picture. The use of a silane agent is not necessary. Fundamentally, CEREC Zirconia Plus restorations can be luted adhesively, self-adhesively, or with a classic water-based cement. Of the composite cements supplied by Dentsply Sirona, Calibra Ceram, together with Prime & Bond Active, Prime & Bond Universal, or Prime & Bond Elect, respectively, are indicated for this purpose. Calibra Universal may also be used. Avoid application of adhesives onto intaglio restoration surfaces that are not indicated as a zirconia primer, such as Prime & Bond Elect. CEREC Zirconia Plus restorations may also be cemented with a classic cement, such as Calibra Bio by Dentsply Sirona. For further details regarding cementation, please see the instructions for use of respective products. We are approaching the end of this presentation. Now we are going to summarize the most important properties of CEREC Zirconia Plus again. CEREC Zirconia Plus's strength is as high as 1,000 megapascals, allowing for a general wall thickness of 0.7 millimeters. The monochromatic blocks of CEREC Zirconia Plus offer enhanced translucency of 45%. Sintering and firing times no longer depend on shade. Please note that somewhat longer sintering times are required. Glaze firing time, though, is slightly shorter. CEREC Zirconia Plus has been approved for both wet and dry milling. Dry milling is, however, recommended. The meso block for implant restorations will be available by early 2022. Regarding price, CEREC Zirconia Plus is and will remain on par with the previous block. It is between 17 and 46% less expensive than its competitor, Katana from CEREC. Once again, we would like to compare CEREC Zirconia Plus with CEREC Katana. CEREC Zirconia Plus is a fourth-generation zirconia ceramic containing 4 mol% yttrium oxide. As Katana contains 5 mol% yttrium oxide, it belongs to the third generation. The Katana product has not only been approved for crowns and bridges, but also for inlays, onlays, and veneers. For these indications, Dentsply Sirona supply CEREC Tessera glass ceramic, which exhibits superior aesthetics and high strength. CEREC Zirconia Plus exhibits a strength value of 1,000 megapascals. The value quoted for Katana is 763 megapascals. CEREC Zirconia Plus requires 0.7 millimeter thick walls for anterior and posterior crowns. For anterior bridges, the required cross-connector area is 9 millimeters square. For posterior bridges, 12 millimeters square are required. In comparison, CEREC Katana requires much thicker walls of 0.8 to 1.0 millimeter, and for bridgework connector areas of 12 and 16 millimeters. Where lasting cementation is concerned, CEREC Zirconia Plus provides total flexibility. Restorations can be luted adhesively, self-adhesively, or with a classic water-based cement. The milling times are comparable for all products listed in the table. Sintering times for CEREC Zirconia Plus are between 15 and 26 minutes. They depend on the wall thickness of the restoration and no longer on the shade selected. Glaze firing is completed in just 7 minutes. This is the end of the presentation. Thank you for being so attentive. We would be delighted if you were to consider CEREC Zirconia Plus, an enrichment to your dental work.